The next challenge is SMarT1. It says I made a small efficient block cipher. It's small because I can fit it on the page, and it's efficient because it only uses the minimal amount of rounds. I didn't even try, but I'm sure it works. Here's some output with the key. Can you get back the flag out? Cool. So this is the Python file they give us. It says, I don't know how to make a good substitution box, so I'll refer to AES. This way I'm not actually rolling my own crypto. So we have an X box. So this is 256 just random integers, as we can see. There's a transpose box. I think this is also similar to AES. So we have an 8x8 matrix. We have an RR. This is going to be used by this roll write function. And cool. So like I said, this is kind of like a baby AES. And what the challenge is doing, let's take a look at the output file. Actually, or two things. First off, there's two secrets, I guess. The first one, there's this mask, which is used at the end, and there's the key. And so what's going to happen is this is a encryption function. It's going to go block by block. It's going to do some operations, very similar to like an AES kind of like function. And we're given a couple of test pairs. So this is the input and this is the output. And then we're also given the encrypted flag. I didn't look at the output file at first, and I thought we had to decrypt both the key and the mask. I thought the challenge was going to be pretty tricky, but we're actually given both the key and the mask, which makes it not too hard of a challenge. I wish I had understood the hint better. You can see SMT is highlighted or uppercased, so we're supposed to use a SAT solver like Z3. I was being dumb at first. I thought Z3 would have a really hard time with SBox, so I didn't actually use Z3 for the whole thing until SMarT2, which I'll talk about in the next video. But if you're looking for a simple way to solve this challenge, I'd look at SMarT2, where just Z3 does everything. But in this case, I ended up going through and just reversing the functions. So this is the solve script. Like I said, we just need to reverse all the different operations that this encryption function does. And we can take a look at, let's take a look at the encryption function. So block is length 8, key is length 12. I'll just put 12 here. It's going to turn into blocks. There's 2 rounds. And for each of these, it's going to XOR the block. On the first round, it's going to XOR the key from values 0 to 8. And on the next one, it goes from 4 to 12. So it's still going to XOR 8 bytes at a time, but just the first 8 and then the last 8. And there's an overlap of 4 bytes. Then for each of the bytes, we're going to do that S blocks rotation. So this is a substitution blocks. The reason I didn't use Z3 was, as soon as I saw this, I didn't think Z3 could handle stuff like this. But it turns out you needed it for SMarT2, and we'll talk about that later. It turns out this is very easy in Z3. Then they're going to do a rotate right. And so this is just like a bit shift operation. RR is just some known array. It's up there. It just holds a couple of values. Then we're going to do this transpose. This is just more bit shifting, and I think it's kind of like a bit shift, but it's more random. And then at the very end, we're going to XOR our block with mask. So we do that twice, and then we return the block. And then there's this ECB, where we're just kind of generating block by block, which is just ECB mode. So like say, I just manually reversed it, wrote the reverse of all operations. So we have the S box, and so then we have S box reverse, and this just takes the values and reverses them. I didn't reverse the transpose, I'll talk about in a second. We were given a rotate right, so I just wrote a rotate left, wrote some asserts to make sure this code worked. There was a transpose function, this function. I didn't feel like trying to reverse this one, so I actually just did it in Z3. I should have done the whole thing in Z3, but I knew that this would be pretty easy to do in Z3, so we have an in block. I create an array of blocks, and these are all just bit vectors of length 8. And then I do the operation. You have to make sure you do this logical shift. I think otherwise Z3 by default does like the wraparound shifting, and you want the shift where it adds the zeros at the end. A common mistake. Then we do the operation, then we just do the solver. We just basically do the reverse of it in the solver. Z3 solves it, and we get out the correct answer. Like I said, I only use Z3 for this tiny little block because I didn't feel like reversing the transpose function. Then I test it and I make sure it works. So I do the real transpose, and then I do the reverse transpose in Z3. We're given the mask from the output file. Here's your real encryption block, and here is my decryption block. Like you can see, it's just 2 rounds, and so I just have the reverse of everything. So like it ends in this XOR and then do transpose, so I start with XOR and do reverse transpose, and then I do like the reverse. So instead of rotate right, we're doing a rotate left. That's box reverse. And so yeah, it just decrypts the functions. So at this point, and then there's the ECB function. So at this point, we load the key from the output file, we load the ciphertext from the output file. I go through the pairs. I think I just assert that the pairs are working correctly because we're given those known test cases. I guess we really didn't even need the pairs for this challenge. But this is just validating that our algorithm works. And then I go through, instead of reusing the ECB function, I just kind of create my own. I just go 8 bytes by 8 bytes and decrypt the flag. Let's see if this is still working. Child.py. Yep, we can see it's decrypting everything. Those are the test cases, and at the very end, we get back our output. Like I said, I kind of wish I had seen that, or seen the hint that was the capital SM and T were all capitalized. Then I would have used C3 for the whole thing, and it would have made it way simpler. But either way, not too bad of a challenge.